Hello and welcome to part 3 of FRC2168's Intro to Java lessons. If you haven't seen lesson 1 and 2, the link to the playlist of these videos will be in the description, so you should definitely watch those first. And I highly recommend watching the lab review videos if you haven't once they're up. But for now, let's get into lesson 3. So first off, a very brief review of the last class. We talked about if and if-else statements, as well as Boolean expressions. We also discussed conditional logic with not, and or. We talked about the syntax of if statements, where you write if, and then in parentheses the condition, and if that condition is true, then the statement is executed. If you have an else statement, then if the condition is false, the else statements are executed. We also went over Boolean truth tables, so this included these logical operators and or, as well as not. Now, a review of class 1. Computers only understand zeros and ones, while humans need to use more high-level languages that are similar to human natural languages. Compilers translate programming languages to machine code, which is called compiling, and Java is the language that our team uses for the robot, and it's also the language that's being taught to you in these lessons. Java compiles to bytecode first, and then uses an interpreter on the computer to convert bytecode to zeros and ones. The interpreter works by converting a single line to bytecode, executing it, then moving on to the next line. The interpreter is called the Java Virtual Machine, and your bytecode can run on any computer as long as a JVM is installed. We wrote our first Java program. We defined terms like class header, class body, method header, method body, and main method, and we learned that every Java program contains a class with a main method. We learned we could use print statements, and we learned some syntax rules, like ending each statement with a semicolon, and like how Java is case-sensitive. We also covered the math operations within Java. We learned about variables and the different data types. Ints store integers, doubles store decimal numbers, strings store strings of characters, and chars store single characters. We also learned about constants, which you can declare as a variable as being constant by using the final keyword. Using the assignment operator, we can assign values to variables. And then we talked about naming conventions for variables and how they're different from constants. And we talked about concatenation. All right, so we're going to now learn about methods. So you've heard of the main method, but we still don't really know what a method is. A method is a group of statements that can be called by its name, similar to how a value stored in a variable is accessed using the variable name. Methods are generally actions that your program will repeat frequently. So let's say we want to write a program that runs multiple lines of code repeatedly, but not consecutively. So let's go to VS Code and create a new file. This file is going to be called cookie counter. So we'll make a file called cookiecounter.java. Then we're just going to create a main method, as always. So public static void main string args. All right, and then we're going to make an integer called num of cookies. And for right now, it's going to be 1. So now let's print, I want some more cookies. So num of cookies is now going to be set to 10. And then we'll say, I baked more cookies. Then we can say how many cookies we have. So I now have num of cookies, cookies. Remember to add those spaces so that way it's a proper sentence. Then let's say I should share these with the programming instructors. How very kind of you. Okay, so now let's say I just found cookie dough on my doorstep. So now num of cookies is 20. Then we'll once again say I baked more cookies, and then we'll print out the number of cookies we have. So I now have num of cookies, cookies. And then, once again, since you're such a generous person, I should share these with the programming instructors. Okay. So let's run this. It does pretty much what it looks like it does. It's really just a bunch of print statements and some variable assignment. So it prints, I want some more cookies, I baked more cookies, I now have 10 cookies. I should share these with the programming instructors. I just found cookie dough on my doorstep, I baked more cookies, I now have 20 cookies. I should share these with the programming instructor. So, okay. It did what we wanted it to, but it was a little bit tedious. Wouldn't it be easier if, instead of repeating these lines of code, we could call them by name? That's exactly what methods allow us to do. So now let's go and make a method. So underneath the main method, but still within the class, is where we're going to write this. So it should not be within this main method. It should be between these two curly brackets. We're going to write public static void, same as what's in this main method header, but then we're going to write get cookie status and open and close the parentheses with nothing in them, and then add curly brackets. Then we're going to say, we're going to copy this and put it in here instead. It did not copy. Oh, you also will notice that our indents are now 2 spaces, like we talked about last time, so that is very fun. Okay, so now this is throwing an error. We just need to move where we define num of cookies, and you'll understand this later, but just move it to up here. And then save. And you also need to make it static. So it should say static int num of cookies equals 1, and again, you'll understand later why we have to do this, but for now, just put it there. If we want num of cookies to be able to be used in both of these methods, we have to define it outside, because these methods have different scopes. So if you remember when we talked about scopes before in lesson 1, I believe, where you can't have two variables with the same name in the same scope, this is what a scope is. The main method has a scope, and this method that we just made has a scope. So you can't use variables from the main method scope in this scope, so you have to write it out here in the class where it's part of both of their scopes. But again, it'll make more sense later on in the lessons. So now we have this code in here. We can replace it everywhere else that we wrote it. So delete that and instead write get cookie status with the parentheses. Then same thing here. Delete this and instead write get cookie status. That is our whole program. Let's go and talk about that. So to break it down, we've talked a bit about method headers before when we were talking about the main method structure, but this is some review. So right here is the method header. It tells us a couple things that we'll understand later, but these are some Java keywords. This is the return data type. And this right here is the method name. So the name is getCookieStatus. Just like a variable has a name, a method has a name. Then in here is the method body, and this is the code that is executed by the method. So the method header defines the return type, more on that later, as well as the name of the method. The body contains the statements that are run when the method is called. So recall that the main method is the method in which we put all of the statements that we want to run. When we make a new method, it does not go inside the main method, but it should still be inside the class. So as I said before, it has to be structured like this, where CookieCounter is the class, and then all methods are inside it, but separate from each other. Since the code within our new method is not in the main method, it won't run unless we write the name of or call that new method. So when we write the name of our method, just like this, Java fills in the statements within the method body for that line. Again, this is just like how Java fills in a variable's value for its name. So if we go back to the code, when we wrote this here, Java looks at that and then evaluates it as all of these. So it's essentially replacing the name with everything that's inside the method's body. So if we run this code, it does the same thing as before. It still says, I baked more cookies, I now have however many cookies, and I should share these. So it's still running these lines of code, but now all we have to do is write the name, because it looks at the name and evaluates the name as these lines. So methods with parameters. Our methods would be a lot more useful if we could input variables into them so that the output isn't always the same. It turns out that we can. Methods with parameters are very similar to functions in math, and unsurprisingly, methods are sometimes referred to as functions. So I believe with JavaScript, they're more often called functions, but in Java, since Java is an object-oriented programming language, they're referred to as methods, I believe that method is the common terminology when it's relevant to object-oriented programming, and we'll learn about object orientation later. But yeah, methods are very similar to functions. So if you've taken any sort of algebra class, you probably have become familiar with functions with this f of x notation. So an example is f of x is 3x. And then down here, if you were to call this function by writing its name, which is f, and then substituting in 5 for x, it then gives you a result where x is replaced with whatever you put in here. So in this case, f of 5 will replace x with 5, and so 3 times 5 is 15. So it's the same thing with methods that have parameters, and that's why they have these parentheses. So if you have a method which is written like this, public static void multiply by 3, and then in the parentheses you define the variable, just like you would put x here. You're defining a variable called number, and then you say, let's print number times 3. These two are essentially the same. Then you call this method and put 5 in the parentheses, and just like with this, it will print out 15 because it replaces number with whatever you put in the parentheses when you call the method. So it replaces number with 5. So we can input a variable to be used in a method, similar to how a value for x is used in a function. So note that you must specify the data type of the input parameter and give it a name. This makes parameters look similar to variable declarations, right? So when we create a int in our code, we would write int and then the name. So this is what this looks like. And in a way, this is a variable declaration. Methods with parameters create sort of temporary variables that are assigned to whatever value is passed in when the method is called. So number right here is being created as an integer, which only exists for this method, and its value is set to whatever you put in these parentheses when you call the method. So these temporary variables only exist within the scope of their method. So again, we're talking about this idea of a scope. If you try to use number outside of this method, it's not going to work because number only exists within this method. It only exists within its scope. That's why we couldn't use num of cookies in the other method, because we created it in main. It only existed within the scope of main. So since variables in programming don't have to be numbers, we can input values other than numbers into methods. You can also input more than one variable. So let's go over to the code and write this stuff down. Now we're going to make a new file called lesson3.java. And oops, I didn't want to do that. We, of course, are going to need a main method. Public static void main string args. And then we'll say we're going to make a username. And we'll set it to Kevin. Then we'll make an integer num of visits, and we'll say it's 10. So we're going to create a little simulation of a website where we have a visitor to the website. So now we're going to make a method, and again, it has to be outside of the main method, but still inside the class. So I'm going to make it right here. public static void, and then the name of the method is greet user. Now, method names should be verbs, action words. So greet user is an action. And then it's going to take in a string called username, as well as an int called times visited. And then curly brackets. So again, these are the parameters. You can have more than one, and they don't have to be ints. So this is just like f of x, but instead of x, you have username and times visited. And f is greet user. So now what we want this to do is to print out a message for the user. So hello, and then we'll take in their name. So we're going to write the name that we've been supplied with when we call the method. So hello username. Thank you for visiting our site. And then we'll say times visited times. And then since this is a long line, we can make it a multi-line statement. So we'll press enter here. And I forgot a plus. And then remember, this needs to be a hanging indent since it's a multi-line statement. So this part of the line, or this line, is indented one more level. And that's that. So this is just saying, okay, when this method is called, I'm going to give it a username and an integer representing the times visited. So it's saying, hello, username that I put in. Thank you for visiting our site. Int I put in, times. So if I call this, I need to give it a username that it's going to say right here. And I need to give it a number that it's going to say right here. So in this case, I'm now going to call the method so that it actually runs, because again, these lines won't be run unless you call it in the main method. Now, for the username, I want to put in this variable I already defined. So the name username is the name of this variable, so I can keep that there. And then for this one, for times visited, I want it to have the value num of visits. So you can use variables, other variables, as the parameters for a method. So you can pass in variables. So this temporary variable username is being set to this variable username. This temporary variable times visited is being set to this variable num of visits. You can also pass in expressions, so I could do like num of visits plus 1. That would work too, but that doesn't make much sense. So it just shows that this works like any other variable declaration. Just as I could say that num of visits is 10 plus 1. I could say that times visited is 10 plus 1. This is just telling times visited what its value is, and this is just telling username what its value is. And also, again, here we have two different variables named username, and again, that only works because they're in two different scopes. This username is in the scope main, and this username only exists in the scope of greet user. So this is allowed because they are in two different scopes. So now when I run this, it says, "Hello, Kevin. Thank you for visiting our site 10 times." So it did put in Kevin for username, and it put in 10 for times visited. Now, methods that return data. We can also create methods that return a value. This means that when we call them, Java evaluates them as whatever value is returned. For example, what if we have a method that evaluates a math equation and we want it to actually use the result? Instead of printing the result, we can return it. So let's go write this in lesson2.java, or lesson3.java. We are on lesson 3 now. So we are making another method. So it's going to, once again, be within the class lesson 3, but still outside of the other two methods. So public static void, actually public static double calculate average it's going to take in two doubles to calculate the mean of. So that's what this method is doing. It's just calculating the average or the mean. So naturally, we do need two numbers to take the average of. Then we are going to write return num1 plus num2 divided by 2. Because of course, adding them and then dividing by 2 will give us the average of these two numbers. So we want to actually use this method, so let's create two data points to use and to find the average of. So let's define double data point 1. Let's say it's 5.0, and then double data point 2 is going to be 7.25. So then we can say we want to print out the mean. So let's say the mean of data point 1 and data point 2 is calculate average of data point 1 and data point 2. This is another long line, so let's make it a multi-line statement right around here, hanging indent. Alright, so if I run this, it's going to print out that the mean of 5 and 7.25 is 6.125. Now, this is probably confusing, so let's break it down. Public static double calculate average double num1 double num2. You might notice that instead of void, we wrote double. Recall that this keyword states what the return type of the method is. So in this case, we are returning a double. Right, so we are returning the average of two numbers, which is a decimal, which is a double. So the return type is double. Void simply means that we are not returning anything, which is why we always used void in the past. And it's also why the main method is a void method. It just doesn't return anything. as usual, we declared the types of the inputs and gave them names. So the first input parameter is a double called num1. The second is a double called num2. Then return num1 plus num2 divided by 2. This line, of course, tells the method what to return. We are returning the average of the two inputted numbers. So then, back in the main method, we wrote system.out.println, the mean of data point 1 and data point 2 is calculate the average of data point 1 and data point 2. So when we call the method, which we did here by writing its name and then putting some parameters in, Java replaces it with the number that the method returns. In this way, we can use methods in a similar way to how we use variables. So with the methods that don't return anything, when we write their name on a line, Java evaluates them as the statements in their method bodies. But with methods that return numbers, Java evaluates them as those statements, but also as what value is returning. So with calculate average, it's going to first run whatever lines are in the method body, and then it's going to evaluate that statement as the number or value it's returning. So again, it's quite similar to how we use variables. So as we wrote this here, calculate average, writing this is just the same as writing the average of the numbers. So if this were a variable that was set to num1 plus num2 divided by 2, it would be the same thing. Java is going to look at data point 1, and it's replacing this with 5. It's going to look at data point 2, and it's evaluating that as 7.25. Then it's going to look at calculate average, and it's evaluating this as whatever it's returning, which in this case was 6.125. Alright, so putting it all together, let's go back to the salary calculator program that we made last lesson. We are asked to update our program so we can calculate the salary for everyone in the office, but they each have a different hourly rate. So what can we do? So first, we'll do it without methods, the way we would before we learned that methods were a thing. So let's go to salarycalculator.java and reopen it. We are going to replace the code that we had before. So first, we need to define each person's pay rate. So we're going to make them constants since they're not going to change. Final double pay rate 1 is going to be Mary's, and hers is 18. So we'll say that this is Mary in a comment. Also note that with doubles, you don't have to do a 0.0, but it's still going to treat this as if it's an 18.0. Anyway, we have final double pay rate 2. This one's going to be John's. His is 20. So then we'll comment that this is John. And then finally we'll do Steve's. So final double pay rate 3 is 17. And this is Steve. Then we'll make a double pay, and for now we'll say it's 0. That's just going to be their paycheck at the end of the week. Then we'll make a string name. So this variable is going to specify whose salary we want to calculate. For now, we'll set it to Mary. if we change the name, it's going to change what salary is calculated. So then we'll make an int hours worked, and it'll be 40. Exactly 40. Okay, so now we get to make a bunch of if statements. If name, and so we want to do if name is Mary, we're going to calculate Mary's pay rate. If name is John, we are going to calculate John's, and if name is Steve, we are going to calculate Steve's. So think back to how we can question whether the name is equal to Mary. What am I going to write in these parentheses? So if we were comparing primitive types, I would use the equals operator, which is 2 equal signs. But since these are strings, I have to not do that. So now we understand that dot equals is a method. I have to do name dot equals and then Mary. So this is now saying if name is equal to Mary. Then we'll calculate her pay rate. But there are still more conditions because we still need to take into account overtime. So if hours worked is less than or equal to 40, she's just going to get her normal pay rate. Pay rate 1 times hours worked. However, otherwise, her pay is going to be pay rate 1 times 40 plus 1.5 times pay rate 1 times hours worked minus 40. So as per last time, she'll get her normal pay rate for the first 40 hours and then the overtime rate for the rest of the time worked. Alright, so then we're going to do the one for John. If name dot equals John, not Mary, John, then it's basically the same thing. If hours worked is less than or equal to 40, then pay is pay rate 2 times hours worked. Otherwise, pay is pay rate 2 times 40 plus 1.5 times pay rate 2 times hours worked minus 40. Alright, and now we just have to do Steve. If name dot equals Steve and pay, or if hours worked is less than or equal to 40. Same thing as before, but it's pay rate 3 this time. that is that. So now we just want to print out the pay so that we can see what it is. So system.out.println pay. So if we run this, we should get Mary's pay. Hers is $7.20. Then if we replace Mary with John, we should get a different number, which is going to be John's pay. He gets $800. And then for Steve, he gets yet another different number. His is $680. Okay. So the previous code works, but we were forced to write the same/similar lines of code multiple times. This is a nightmare for code maintenance. And wasn't that just so tedious? It was. So now let's do it a better way using a method. Back to the code. Alright, so as per usual, outside the main method but still in the class is where we are going to write our method. So let's do public static double. It's going to return a salary. Calculate salary. Again, we want to be a verb. And then it's going to take in parameters. The parameters are going to be the hours and the pay rate. And remember that all pay rates are constants, so we have to make sure that it's a constant here as well. So yes, in order to calculate someone's salary, we need the number of hours they worked as well as their pay rate. So then we can use that information to return a value. So here we're going to return a different number based on conditions. So you can in fact do that. So if hours is less than or equal to 40, we get to do the normal rate. So we would return hours times pay rate. And otherwise, we are going to return 40 times pay rate plus 1.5 times pay rate times hours minus 40. And that is much simpler. And now we can just replace all of this with that method. So if name is Mary, we will say that pay is equal to whatever calculate salary returns when hours is hours worked, and pay rate is Mary's pay rate 1. Then if name is John, same thing. We're going to set pay to the value that's returned from calculate salary when hours is hours worked, and pay rate is pay rate 2, John's pay rate. And I need semicolons. And finally, for Steve, same thing. And isn't that much cleaner, much simpler, much nicer? And again, with a return value right here, a return type, this method is returning something. It absolutely has to return a value if you are telling it that it's going to. So if I didn't have this else statement, then that means it's only going to return something under this condition, otherwise it's not going to return something, and so it freaks out, because it must return a result of type double. That's why we need this else. We always need to make sure it's returning something. So if you didn't know what you wanted it to return under a different condition, you could just have it like return, say, 0. But in this case, we do know what we want in both situations. We have very specific things that we want in both situations. And also, you can use conditional logic for returning things. So you can return one thing in one situation and another thing in another situation. And this shows that the method isn't always going to return the same value. Each person's pay is going to end up being different, so it's going to return a different number based on what parameters we put in. A different pay rate will result in a different value returned. One last thing you should know: if you put any code after the return, it's not going to be run, because once a value is returned, it kind of boots out of the method. So the return is the very last statement in the method. But since this is conditional, we can still have lines of code after this, because if this isn't true, this just isn't run. So yes, if we run this code, it should give us the same result. Steve's pay should still be $680, and indeed it is. So you can try running each person's name, but for now, let's go back to the slides. Alright, so we're going to break it down, and I did explain it, but maybe this will be helpful. So again, this is a method header. So we have public static double. Double is the return type. Salary, we wrote calculate salary because it should be a verb, but this is the method name. Here are the input parameters, and then in the method body is the code that's run. Return is a Java keyword used to output this expression's result from the method. So yes, what we just wrote is clearer, more concise code. You can reuse code multiple times while only having to write it once. Okay, so now let's talk about objects. This is where we get into object-oriented programming. So Java is known as an object-oriented programming language, which can be abbreviated to OOP. So today we're going to talk about what that means and how we can use it in our programs. The world around us is made up of objects: people, automobiles, buildings, streets, and paper, for instance. Each of these objects can perform some action and affect other objects in the world. Object-oriented programming is a programming methodology which similarly contains objects that perform actions. Object-oriented programming has its own terminology. The objects we define are called, appropriately enough, objects. The actions that an object can perform are called methods, which we have just learned about. Objects of the same kind are said to be of the same type or in the same class. And all objects of the same class can perform the same actions, again, called methods. For example, in an airport simulation program, we might define an airplane object. All airplanes belong to the same class, probably called the airplane class. All airplanes have the same methods, such as taking off, flying to a new location, landing, etc. However, all airplanes are not identical, and they can have different characteristics. For example, each plane can be flying at a different speed or altitude. So every airplane will have these characteristics. All airplanes will have a speed and will have an altitude, but they aren't always going to be the same for each one. Even if two objects are of the same type, they can have differences, i.e. different data. So far, we have been using the data types known as int, double, boolean, and string, among others. Recall that these are predefined in Java and are called primitive data types, except for the string. You can think of objects as custom data types that the user can create in Java. The way you define your object is in a class. So with objects, you can basically make variables using them as the data type, just like you can make an int variable or a double variable. Every time you make a new variable using your object, you can say that the variable is an instance of that object. For example, if you create an airplane variable called airplane1, it is an instance of the airplane object. An object differs from a primitive type in that objects have data as well as methods, whereas primitive types only store data. So objects can contain their own variables of other types, as well as, of course, containing methods. So, for example, the airplane object might have an integer variable within it for its altitude, although that would probably be a double. And it also might have a double variable within it for its speed. And then, of course, it would have the methods that were talked about before. Whereas, of course, other primitive types do not have variables within them or methods. They are just themselves. So strings, we've said they are not primitive types. Strings are actually objects, and that's why they have methods like the .equals or .equals ignore case method. And that's why we can't compare them using the is=to operator. Class definitions. Let's create our first object. So back to VS Code. Let's make a new file called date.java. So here it says public class date. So as it said, objects are created using classes. So this is a class. Every file is going to have a class in it. But in this case, this class is going to be used in an object-oriented way. So now let's make some variables that date is going to have. Public string month, because of course dates have months. Then public int day, because dates have days. And public int year. So then we also want the date to have a method. Public void. It's not returning anything, so it's void. Write output. So we want write output to just print out the actual date itself, so the month, the day, and the year. So let's do system.out.println, and then do month plus the space plus the day, and then a comma and the year. So this is going to print out the date. As the slide said, this has to be saved in a file called date.java because files always have to have the same names as the main class in it. So let's break this down. The class named date is unrealistically simple, but it will help you learn the syntax for creating an object. Each object of this class has 3 pieces of data associated with it: a string for the month, an int for the day, and another int for the year. The word public is a keyword, and it simply means there are no restrictions on how we can use these variables when we use this class in our programs. So when you make objects, you'll generally want to use them in other files. So you create a file with a class where you sort of define the object and all the variables and methods it has, but then when you actually use the object and create variables out of it, you're going to do that in a different file. So for us, we'd do that in a file that has a main method in it. So if you noticed, date.java did not have a main method because we are not actually running code out of it, we are just creating an object with it. And then again, we create instances of the object or variables using it as the data type in another file with a main method. So these variables being public just means that we can use them in other files. We'll talk more about what public and its alternative private mean later. There's also another one called protected, but we don't go too in depth about that, I don't think. Now, the objects only have one method, and it's called writeOutput. So now we can use this object in a program as I was just talking about. So again, we are not going to use it in date.java itself, but we're going to go back and use it in lesson3.java. So let's see. We're going to create a date object in the main method of lesson 3. So make sure you're in the main method. I'm on line 13, and I'm going to do date, date 1, date 2. So you can declare two variables of the same type on the same line as long as you're not initializing them. So I could do the same thing with an int. I could say int number 1, number 2. That was number 2. And this is just declaring them both at once without initializing them. So I'm now creating two dates on the same line, but not initializing them. Then I'm going to say date 1 is new date with parentheses, and the D has to be capital. Then same thing for date 2. Date 2 is new date. Then we're going to set the individual variables within them. So date 1 dot month equals December. Date 1 dot day equals 31. And date 1 dot year equals 2007. Then let's print that this is date 1. And then we're going to run writeOutput, which will write the actual date. So this is saying, okay, this is date 1, and then this is going to write the actual date. Then we have date 2 dot month is going to be July. Date 2 dot day is 4. And date 2 dot year is 1776. So then we'll do the same thing. Date 2 and then date 2 dot writeOutput. All right. Let's break it down. This declares two new variables, date 1 and date 2 of type date, similar to how we declare variables of int or double. So again, we are just using the date object that we made as a data type, just like an int or a string or a double. This gives us variables of type date, but we still need to initialize them with an object. So we do date 1 equals new date, and date 2 equals new date. This is just like assigning 4 to an int or hello world to a string. So, if I did int num1 is 4 It's the same thing as saying date 1 is new date. We're going to discuss this kind of statement in more detail later in, I believe, lesson 5, when we go over something called a constructor. But for right now, just remember that we use the new operator to initialize an object. So here's class definition syntax. We have file classname.java, and then it says public class name. Then we have int x, y, char. So this is just some example variables. These are the member variables of the object or the class. So you define the variables that belong to the object at the top, and then you write the methods in the rest of the class body. So now let's go in more depth about instance variables and methods. Each object, or each instance of the object, has its own copy of the member variables, which can be used like any other variable. So date1 has the following instance variables. It has date1.month, date1.day, and date1.year. Date2 has the following instance variables, which are of the same type, but can have different values. So date2 has date2.month, date2.day, and date2.year. We can access instance variables and methods by using the dot operator. So in all of those cases, we have to do dot and then the name of the variable. Instance variables can be used like any other variable. For example, date2.month can be used like any other string, and instance variables date2.year and date2.day can be used like any other int. So even though the below doesn't make sense in context, it's possible to do the following. You could set date2.month to hello falcons, you could set the day to 36, and you could set the year to -3. Now, with knowing what these variables are supposed to be used for, this doesn't make sense to us as humans, but since these are just normal variables like any other, there's nothing stopping us from giving them nonsense values as long as it matches the data type. So yeah, month can be given any string value, day and year can be given any integer value, even if it doesn't make sense in context. Later on, we're going to see how to prevent incorrect values from being assigned to our member variables. So for now, just know that this is possible. Okay, so far the class we defined has only one method, which is named writeOutput. So again, method header and then method body. Every time we call this method using date1.writeOutput or date2.writeOutput, the code inside the method will execute for that instance only. So date1.writeOutput will only output the values stored in date1, and date2.writeOutput will only output the values stored in date2. So this would just write the date of date1, and this would write the date of date2. So if we go back to our program and actually run it, we will see that that is in fact the case. So it says date 1 is December 31st, 2007, which is what we set these values to. And it says date 2 is July 4th, 1776, which is what we set these values to. So date1.writeOutput is printing out the date stored in date 1, and date2.writeOutput is outputting the date stored in date 2. The new operator. An object of a class is named or declared by a variable of the class type. So we did date, date 1, and date, date 2. So you would just do the class name and then the name of the variable or the instance. The new operator must then be used to create the object and associate it with its variable name. However, some exceptions do exist. So we did date 1 equals new date, and then date 2 equals new date. So you would just do the name of the variable, is, and then the new operator, and then the name of the class that is the data type. So it says that some exceptions exist. So for example, with strings, we said that strings are objects, but you don't have to do this syntax when you create a string. So that would be one exception, but for the most part, if you're creating objects and then making variables out of them, you're going to be initializing them just like this. So, of course, these two statements can be combined as follows, where you declare and initialize it in the same statement. Class name, object name equals new class name. So here's an example where we have a car object. So car is the name of the object and also the class that it's defined in. So then we have a car, and we are naming it C1. So this is one variable or one instance of a car. Then we're saying it's a new car. So car is the class name and C1 is the instance name. Member variables or attributes can be defined as in the following two examples. Note the public modifier for now. So this is going back to the car example. In the car class, car.java, you would put public int number of doors and public double price at the top to declare these as member variables of a car. So then each car would have a number of doors or have a price. Then when we access that variable from an object we created, so if we made C1, which is an instance of a car, we can access its member variables, number of doors, and price. But in order to do so, we have to preface it with its object name. So the name of the variable. So if we had a car named C1, just like having an int named my number, this is a car variable that we made called C1. In order to get its price, you would just do C1.price, C2.price, C2.number of doors. So this is giving you the price of C1, this is giving you the price of C2, this is giving you the number of doors of C2. C1 and C2 are just two objects from the class car. Method definitions are divided into two parts, a heading and a method body. So this is just review of what we've already talked about. Methods are invoked using the name of the object and the method name. So you would do the name of the variable dot the name of the method. So the example would be C1 dot get number of doors. So if all cars have this method, then an instance of a car has this method. So the instance name dot the name of the method. Invoking or calling a method is equivalent to executing the method body. So it's the same as calling a method normally when it's not associated with an object. More on methods, this is also pretty much review. As we noted, the methods you can define are of two types, methods that perform an action and return a value, and methods that perform an action but don't return a value. So technically, you could have a method that returns something and does nothing else, and so those methods would only be able to be used in expressions, but I'll talk about that a little later. So both kinds of methods have a method header and a method body. This is an example of a method header, public void method name parameter list. This does not return a value because it is void. Again, void just means that it's not going to return something. Then all of these would return a value. So public, and then you put the return type, the method name, and the list of parameters if there are any. Public string my method. This is an example method header that would return a string. Public double your method. A method with this as its header would return a double. If a method returns a value, it may return different values in different situations. So we saw that with salary calculator. It returned a different number based on the pay rate as well as based on how many hours were worked, but it's always going to return a value of the specified return type. So this is always going to return a string, this is always going to return a double. When a method returns a value, it can be used as an expression in an assignment. So you could do a double named D equals an object dot your method. This is only going to work if this method returns something, because otherwise it's not going to be evaluated as a value, so it won't be able to be used to set a number, or, well, yes, this is a number. Similar example, string sysoutput is an object dot my method. Whoops. A void method does not return a value but simply performs an action. So an object dot our method, if this is void, it would have to be used alone on a line. If you try to use this in an expression, it's not going to work because it's not returning anything. So if I had a method that's a void, and I tried to set it as the value of a variable, it doesn't work because, like, what value is that? It's not one. You can only use a method in an expression if it is returning something. Because if it's returning something, it's going to be evaluated by Java as a value. Otherwise, it's just going to tell Java to run the lines in its body. And you can't do that to set a variable, you know? Also note that if a method only contains a return statement, doing nothing but calling it in a line of code won't actually do anything. So the returned value will be used if the method is called in an expression. Let me give some examples of what I'm talking about. So this is void. It's not returning anything. All it's doing is printing something out. So if I try to make int a number and then set it to greet user, it's not going to work because it can't convert from void to int. This is not being evaluated as a number, it's being evaluated as lines of code. So you can't set this as a variable. But I could do, as we did, sort of, double a number is calculate average of two numbers. Because this is returning something. This is returning the average, so it's being evaluated as a number. So this double is being set to what this is returning. But if you just put calculate average alone on a line, it's not illegal, but it doesn't actually do anything. Because, again, calculate average is only returning something. It's not doing anything else. So this would be the same as just writing 0 on a line. It's not going to do anything. Now, if you had something else in here, like if you had a print statement, then you could write this alone on a line and it would print what I told it to, but then this thing that's being returned just doesn't go anywhere. It essentially is like this isn't happening because I'm not trying to use the number it's returning. But it is going to evaluate this line of code that's in the body. And if I did still want to set this to something, my number will be set to what it's returning, and this line of code will be run. So it's still going to print hello, and it's going to actually use this value that's being returned by setting it to my number, or setting my number to it. So, yes, methods can be somewhat complicated, but the more you use them, the more it'll make sense intuitively. Okay, so setters and getters. Setters and getters are specific types of methods that are used to manipulate and access values. Setters are methods that allow you to set the value of one or more instance variables, while getters are methods that return or get the values of instance variables. So, setters and getters aren't special types of methods, they're just the names that we give to methods that we use for these purposes. So, they're still just methods that do something or methods that return something. We just give them special names because we use them for specific purposes, which is for setting member variables or returning member variables. So the name is arbitrary, but we use methods that do these things a lot. In Java, you can only return one value per method, so getters can only get one value, but setters can set multiple values, since you can, put as many lines of code as you want in a method, so you can set as many variables as you want in a method, but you can only return one value at once, so getters can only get one value. The way around that would be to make an array of values and then return that array. So we do that sometimes in our robot code where, let's say we want to get wheel speeds, we would make an array of wheel speeds and we could return that array in order to get all of them at once. So here's just more examples. If we had a car, we could do c1.setPrice, and then this is setting the variable price to 300. That is presumably what you would define this to do. It would do the same thing as c1.price equals 100. And then c1.getNumberOfDoors most likely is just returning the number of doors variable that's stored within c1. So it does the same thing as c1.NumberOfDoors. Now, this might be confusing. Why would we use methods to do this if we can just access the variables directly? Why use setPrice when we can do c1.price equals 300? Why use getNumberOfDoors when you can just do numberOfDoors? Next lesson, we'll talk about why we would want to use setters and getters as opposed to directly calling variables, but it has to do with that thing we were talking about before, where you can change or where you can set variables to any number you want with no restrictions, or any string you want with no restrictions. Using setters and getters allows us to have more control, but again, we'll go into detail about that later. Now let's add setters and getters to our code. So back in date.java, we are going to add setters and getters for our 3 member variables. So we'll do public void, since this is going to be a setter, set month. So this method is just going to set month to whatever we input when we call it. So we want the parameter to be a string, and we'll call it m. So then we'll say month is m. Month is whatever value we put in here when we call this method. Public void set day. Same thing, but it's going to be an int. So we're going to set the integer day to whatever we input in the parameter when we call this method. Set year, again, is the same idea. Then for the getters, they're just going to return these numbers and the string in the case of the month. So public string, this is going to return a string. get month. No parameters because we don't need to do anything with any inputted number. All we are doing is returning the month of this date. Then public int, we are going to return an int, get day, return day. And finally, public int get year, we return the year. So now we can actually use these methods in lesson 3.java. So here's what we're going to do. For date 1, we are going to replace this direct accessing of the variables with using methods. So instead of doing date1.month equals December, we can do date1.set month and then put December as the input. We can do date1.setDay, and then do 31 as the input. And this is doing the same thing as saying date1.day equals 31, because that is what we told the method to do. Day equals whatever we input. Then we can do date1.set year, and we'll do 2007. Then I'm just going to add, that way we can use the getter, a print statement. The month of date 1 is, and then we'll concatenate that with date1.getMonth. Then with date 2, we're going to keep it with variables, accessing them directly, just so that you can see that they both work. So for date 2, I'm going to add the month of date 2 is, and then date 2 dot month. I forgot the plus. Okay, so again, date1.setMonth is just going to take whatever the parameter is and set date1.month to that. Same thing with day, it's taking the parameter and setting date1.day to that. Same thing with year, taking the parameter, setting date1.year to that. Then date1.getMonth is just going to return date1.month. For date 2, we just have it setting the month of date 2 directly, setting the day of date 2 directly, and then we get the month of date 2 directly. So if we run this, they're both going to do the same. For date 1, it still says December 31st, 2007, as it should, and it says the month of date 1 is December. Date 2 still acts the same, and it says the month of date 2 is July. So both of these ways of doing it work. Now let's talk about the static keyword. You may have noticed that we are no longer including the static keyword in our method headers. So we used to put public static as the first two words of methods. This is because static cannot be used for instance variables and methods. So static is essentially used when you want something to not be treated as object-oriented. So both variables and methods can be static. When something is static, it just means that it's the same for all instances of that object. So rather than each instance having its own variable or its own method, if something is static, it applies to all instances as a whole, the object as a whole. A static variable will belong to the class as a whole rather than to each instance, and the same can be said for static methods. For example, we have learned that instances each have their own copy of each member variable. But what about values that will be the same for every object of a certain class? So let's say we have a circle object. Circles may all have different diameters and circumferences, but pi is always the same regardless of the circle's attribute. So we wouldn't ask, what is this circle's pi, in the same way that we would ask, what is this circle's circumference? As such, pi would be a static variable, while circumference and diameter would be normal number variables. So the reason we would have pi at all is because it's very useful when it comes to circles, but again, it's not something that applies to each circle individually, it's just a whole truth for circles in general. Pi would also be a final variable, it'd be a constant, because its value is never going to change. Static variables don't need to be constants, they can change, but the changed value will apply to all instances of that object. So for another example, let's say we have wheels on our robot, of course, and let's say we want all wheels to have the same maximum speed, because if they had different maximum speeds, then if we used a percent control style, it would never be able to go straight. So we want them all to have the same maximum speed. But that speed might change depending on what mode the robot is in. So let's just say for some reason we have a mode where we want the robot to drive on carpet and then a mode when it's driving on concrete. And let's just say we want the maximum speeds to differ based on what it's driving on or just what mode it's in. The maximum speed for the wheels might change, but no matter what, it's the same for all of them. It's going to apply to all of them. So that variable is static, because it's not like each wheel has its own maximum speed. Maximum speed belongs to our wheels in general as a whole. So static methods are methods that do not perform an action on a single instance, but on the class as a whole. Static methods often come in the form of setters and getters that interact with static variables. If you try to access normal member variables using static methods, the code will throw an error because it doesn't know which instance's copy of the variable you're trying to access. So if you have, a normal member variable, which each different instance has its own copy of, and then you have a method that applies to the class as a whole, and you call it, it doesn't know which member variable you're trying to access. For instance, if calculate circumference were a static method, it would be like saying calculate the circumference of circles. What circles? So since calculate circumference has to interact with non-static variables, it needs to know the circle's diameter and things like that. You wouldn't be able to use it statically. You can't use it on the class as a whole when it needs to know one specific circle's member variables, one specific circle's diameter. So a method like that would not be able to be static. Accessing static variables and methods. To access instance variables and methods, we write the instance name, use the dot operator, and then write the variable or method name. So with the circle example, it would be circle1.getDiameter. How do we access static variables and methods, though? We write the name of the class and then the name of the variable or method. So if we wanted to set a variable to pi, and pi is a static variable that belongs to circle, you would do circle, which is the name of the object and the name of the class, dot pi. So it seems to make sense. Yes, instead of doing the instance name, since it doesn't belong to just one instance, you would do the class name, since it belongs to the class as a whole. Also, as a side note, for placeholder variables, it's common practice to use the word foo, or the word bar, or foo bar. So if you see that, it's just because it's often used as a placeholder variable name, just like John Smith is often used as a human placeholder name. Alright, so the static keyword essentially makes a variable or method non-object oriented. This means that the reason we were using it in our methods before was because we were not doing object-oriented programming. So with, say, salary calculator, we didn't want it to be used as an object. We didn't want to have to make an instance of a salary calculator. We didn't want to use it as a variable because there was only one salary calculator. There was only one pay rate 1 for Mary, only one pay rate 2 for John. We didn't want it to be object-oriented, so we made it static. When you have a class that you don't want to be an object, use the static keyword to ensure the methods and variables are accessed using the class itself rather than through instances. When we created variables in the main method, we didn't need to use the static keyword because those were not member variables. They only existed within the scope of main. So let's actually use the static keyword now. In date, we can go up here, and let's say we want to add months per year as a variable. The number of months in a year would be static because, of course, it's not going to change based on the date, right? On Christmas, it's the same number of months in a year as on Thanksgiving. So you wouldn't ever say, how many months per year are there today? It's always the same. It applies to every date. It applies to dates as a whole. So it would be static. So let's do public static. It would also be final because the number of months per year isn't going to change. So months per year is 12. Oh, right. I need to make a data type. Okay. It is an int. Okay. So then let's add a getter. Underneath all of this method needs to be static because we're accessing a static variable. Technically it doesn't need to be, but it doesn't make much sense to do date1 dot get number of days per year because again, it's static. It doesn't just apply to date 1, it applies to all dates. So this method should be static. Public static int, because we are returning an int. Get months per year. And then we will just return months per year. So now let's go back to lesson 3 and let's try and just print this value. This is a shortcut that you probably saw me using. If you just do sysout and then press enter, it'll autofill this for you most of the time. But I recommend for beginners to type it out as much as possible so that you remember the full thing, because if you get serious about programming and do job interviews, a lot of people will have you write code on a whiteboard and things like that. So you'll need to remember what different functions and such are. So you'll need to know system.out.println instead of just, oh, I type sysout and press enter and it's there for me and I don't need to remember. So I recommend typing it out, but still, that is the shortcut I've been using. Anyhow, we'll do, well, first, do you remember how we call a static method within an object? The way we do it is by writing the class name, because it applies to the class as a whole. Then we do dot, and then the name of the method or the name of the variable. So date.get months per year. And then it should just print out 12. And so it does. Now, if I were to do this same thing, but I tried to access it through an instance, it will work, but it's going to yell at me. So the code should run, because this still technically is possible. Date1 is a date, so it does have get months per year as a method, but this method is static. So I'm not accessing it in a static way right now, and that just isn't pretty. It'll work, but it's gross. The static method get months per year from the type date should be accessed in a static way. So you might see this pop up a lot. It's just saying that this method is static and you're trying to access it as if it's not. So you're saying, how many months per year is it during December 31st? How many months per year is it on that particular date? And that just doesn't make sense. So it should be done by doing the name of the class dot the name of the method or variable if that method or variable is static. Now that is the end of the lesson. Hopefully it wasn't too confusing, but I hope that it was educational, and hope to see you for lesson 4. Make sure that you do the lab review video once it's up, and thanks for watching.